Hello everyone, this is Richard again. I just wanted to make a quick video explaining something related to the calculation we just did about going from a velocity graph to a position graph. So you may have heard it said that in going from a velocity graph to a position graph, what you do is you take the area under the curve of the velocity graph. Now what does this exactly mean? What does an area have anything to do with going from velocity to position? So I just wanted to explain that quickly. So to see this, let's go back to the first calculation we did, where I asked the question, if you're going 60 miles per hour for 1 hour, how far did you go? And of course the calculation to do is doing 60 miles per hour for 1 hour, and that equals 60 miles. Now, let's notice something interesting. So how exactly, let's look a little bit about how we're representing our velocity data. We're representing it with a graph. And you can see here, in particular, how we're kind of doing this calculation with rectangles in this way. Let me be clear about what I mean. So you see here, the height of this thing, the height is at a value of, would be 60 miles per hour in that way. And if you look, the width of it looks to be 1 hour. Now what does it mean for a height to be 60 miles per hour and a width to be 1 hour? Well, it doesn't really mean anything. All we're really doing here is making an analogy to the fact that we're representing our velocity data in a graph format like this, and making an analogy to how we do a calculation, or really making an analogy to how in this representation the height is 60 miles per hour and the width is 1 hour. That's an analogy we're making. So, let's say we wanted to get the area of this square or rectangle here. Well, how would you do it? Well, clearly it's the height times the width, but here in our case, the width here looks to be 1 hour, and the height 60 miles per hour. And you see here, when thought about in this way in height and width, we get exactly the calculation for when we are going from velocity to position. Going from 60 miles per hour, or doing 60 miles per hour times 1 hour gives us 60 miles. And you see in this way, the 60, a height times a width is equal to an area. So therefore there's an analogous comparison we make between area and the 60 miles. But really there's nothing special or fancy here about this area under the curve thing. It's just noting the similarity between when we want to do a calculation going from velocity to position, how that's when we represent velocity in this graphical format way, how it's very similar to getting the area of all this. So for example, when we did that calculation before where we got this 195 number, what we did is, of course, we took the 60 miles per hour times 1 hour plus the 120 miles per hour times 1 hour plus the 30 miles per hour times the half an hour, when we wanted how far the thing went in the 2.5 hours. This was the calculation we did, and we got 195 from that. But you see here, that's exactly what you would do if you wanted to sort of find the area of this shape here. Well, it's just the area of this rectangle times the area of that rectangle times the area of that rectangle. And if you represent, the heights of the rectangles by their velocities and the widths by the time, you get the exact same calculation we just did over here. So that's really what we're meaning when we say going from position, or going from velocity position, is an area under the curve. It's a sort of analogous area under the curve in that way.